So over the past few days, OpenAI has been moving pretty fast. It started with a single word appearing in GitHub, caribou. That name turned out to be OpenAI's newest codex model, built on GPT 5.2. At the same time, OpenAI is tightening teen safety rules under political pressure. Luma just unlocked full control over AI video with start and end frames, and Meta is preparing a last-ditch AI reset with models called Mango and Avocado. Some big updates just landed, so let's talk about it. All right, the story really begins with GPT 5.2. OpenAI described it as its most capable model series yet for professional knowledge work, and that framing is important. This was clearly aimed at people doing real work, long tasks, messy repos, lots of moving pieces. Codex was always going to be the next stop once OpenAI set that tone. So, devs started noticing changes inside OpenAI's Codex repositories on GitHub, specifically references to a new model internally codenamed Caribou. At first, this looked like another internal test, the kind that sometimes never sees the light of day. But the naming showed up in the model selector itself, which is usually the last place OpenAI touches before something goes live. That was the first strong signal that this was not just an experiment. What made this interesting is what was missing. In previous codex cycles, there was a clear separation between the standard version and a so-called max tier. That higher tier usually sat behind a higher price or limited access and carried the best reasoning and performance. With Caribou, there were no signs of a max variant at all. Instead, everything pointed toward a single baseline experience, built directly on GPT 5.2. That choice is not accidental though. OpenAI has been under growing pressure lately, especially with Google and Anthropic closing the gap and, in some areas, pushing ahead on accuracy and reliability. Reports suggested that Gemini 3 caught Sam Altman's attention internally, and that timing lines up almost perfectly with GPT 5.2 landing when it did. Rather than fragmenting performance across tiers, OpenAI seems to be consolidating around one strong core and rolling it out everywhere. At the same time, OpenAI was releasing Image 1.5 and referencing multiple internal upgrades in rapid succession. Anyway, on December 19th, OpenAI officially launched GPT 5.2 Codex, ending the internal Caribou codename. The model went live across Codex surfaces for paid ChatGPT users, with API access planned shortly after. Now, this new Codex variant is tuned specifically for agentic coding, and that word matters. The focus here is obviously not autocomplete or single-shot snippets. It's long-running tasks, large repositories, refactors, migrations, and workflows that stretch over hours rather than minutes. To make that work, OpenAI leaned heavily on context compaction, which allows the model to preserve coherence even as conversations and tasks grow massive. One of the standout improvements is how the model handles long context without spiraling into confusion or bloated token usage. OpenAI claims it stays token efficient while still tracking complex state, which is exactly what breaks most coding assistants once projects get real. It also shows stronger tool calling reliability, which is critical when you're chaining commands, running tests, and iterating inside something like the Codex CLI. Speaking of the CLI, GPT 5.2 Codex is fully integrated there, including native Windows performance improvements. That might sound minor, but anyone who has tried serious AI tooling on Windows knows how often it becomes an afterthought. This release directly targets professional developers working on Windows setups, not just cloud-first workflows. On benchmarks, OpenAI says GPT 5.2 Codex achieves state-of-the-art results on SWE Bench Pro and Terminal Bench 2.0. Those benchmarks focus on real software engineering tasks rather than toy problems, so improvements there tend to translate into actual productivity gains. Early developer reactions suggest the model feels methodical rather than flashy, which is exactly what you want when debugging or refactoring large codebases. Another important piece is vision support. GPT 5.2 Codex can interpret screenshots, diagrams, charts, and UI mockups, then translate those directly into functional prototypes. That closes a gap between design and implementation that usually requires several handoffs. For teams working on internal tools or fast-moving products, that kind of capability changes how early prototypes get built. There is also a security angle here, and OpenAI leaned into it more than usual. The company highlighted recent disclosures around React server components from December 11th, where a principal security engineer used Codex workflows for environment setup and fuzzing to uncover additional issues responsibly. This is a subtle signal that OpenAI sees Codex not just as a coding assistant, but as a defensive tool. To support that, OpenAI is piloting an invite-only trusted access track for vetted defenders. This includes safeguards like agent sandboxing and configurable network access, which shows they are aware of the risks that come with powerful agentic models. Early discussions among developers emphasize Codex's bug-finding abilities, but also stress the importance of preserving reasoning quality as these systems get more autonomous. While all of this was happening on the developer side, OpenAI was also dealing with a very different kind of pressure. Concerns around AI's impact on teenagers have been escalating fast, and OpenAI responded by updating its behavior guidelines for users under 18. These changes come amid growing scrutiny from lawmakers, educators, and child safety advocates, especially after reports that several teenagers allegedly died by suicide following prolonged interactions with AI chatbots. Gen Z, defined here as people born between 1997 and 2012, represents the most active group of chatbot users, which puts OpenAI directly in the spotlight. The situation is becoming even more sensitive as OpenAI expands its reach through partnerships, including a recent deal with Disney. That kind of mainstream exposure almost guarantees more young users, whether OpenAI intends it or not. At the same time, 42 state attorneys general recently signed a letter urging big tech companies to implement stronger safeguards for children and vulnerable users. On the federal level, the political pressure is also building. As the Trump administration works through what a national AI regulatory framework might look like, figures like Senator Josh Hawley have introduced legislation that would ban minors from interacting with AI chatbots entirely. That proposal alone signals how high the stakes have become. In response, OpenAI updated its model spec, which governs how its large language models behave. These updates reinforce existing prohibitions against generating sexual content involving minors, encouraging self-harm, or fueling delusions and manic behavior. But they also go further, especially when it comes to emotional interaction. For teenage users, models are now instructed to avoid immersive romantic roleplay, first-person intimacy, and first-person sexual or violent roleplay, even when it is non-graphic. There is also extra caution around topics like body image and disordered eating, and a clear directive to prioritize safety over autonomy when harm is involved. Another important change is how OpenAI plans to enforce these rules. An upcoming age prediction model is designed to identify when an account likely belongs to a minor and automatically apply teen-specific safeguards. These restrictions are meant to hold even when prompts are framed as fictional, hypothetical, historical, or educational, which are common ways users try to push models past their guardrails. Whether these policies translate cleanly into practice is still an open question, but the intent is clear. OpenAI is trying to preempt regulatory action by showing that it takes youth safety seriously, even if that comes at the cost of limiting certain types of interaction. All right, now, while OpenAI was tightening controls on one side and pushing performance on another, the generative video space was making its own leap forward. Luma, backed by a 16Z, released a new model called Ray 3 Modify, and it quietly solves one of the hardest problems in AI video. The core issue has always been control. Generative video models are expressive, but they tend to drift. Movements change, timing slips, identity breaks. Ray 3 Modify tackles that by letting creators work directly with existing footage. Instead of generating everything from scratch, users can feed in real video, provide character reference images, and modify the scene while preserving the original performance. That means the actor's motion, timing, eyeline, and emotional delivery stay intact. At the same time, creators can transform the appearance, change locations, swap costumes, or even rework scenes without reshooting. The model also supports start and end frames, allowing users to guide transitions precisely and maintain continuity across shots. For creative studios, this is a big deal. It allows teams to capture performances with a camera, then use AI to reshape the scene afterward, rather than rebuilding everything digitally. Luma made it clear that this is about blending the real world with AI expressivity, rather than replacing human input altogether. Ray 3 Modify is available through Luma's Dream Machine platform, and it builds on video modification features the company introduced earlier this year. This release also lands shortly after a massive funding round. Luma raised $900 million in November, led by a Saudi Arabia-backed AI company, with participation from existing investors like a 16Z, Amplify Partners, and Matrix Partners. Beyond software, Luma is also planning to build a 2-gigawatt AI cluster in Saudi Arabia, alongside its new partner. That kind of infrastructure investment signals long-term ambition, not just a feature release. Finally, there's Meta, which is taking a different path but facing its own pressure. Internal discussions reveal that Meta plans to launch new AI models for images and video under the codename Mango, along with a text model called Avocado, sometime in the first half of 2026. These plans came up during an internal question and answer session involving Alexander Wang from Scale AI and Meta's leadership. The goal is to make the text model more suitable for coding and to explore new world models that can understand visual information, think, plan, and act without being explicitly trained on every scenario. Right now, Meta is behind OpenAI, Anthropic, and Google in the AI race. Over the past year, its AI division has gone through major restructuring, including personnel changes and aggressive hiring from competitors. Yann LeCun, Meta's chief AI scientist, recently announced his departure to start his own company, which added to the sense of transition. Meta also does not currently have a clear breakout AI product. Its assistant's usage is largely sustained by being embedded into existing social platforms with billions of users, rather than organic demand for the AI itself. That puts extra pressure on Mango and Avocado to deliver something meaningful. If successful, these models could reshape how Meta approaches image and video creation, especially given its unmatched distribution across social apps. Even if Meta has not demonstrated leadership across all AI domains yet, its ability to integrate new models at scale remains a powerful advantage. So yeah, that's where things stand right now, and the pace is obviously not slowing down. I'll keep covering the updates as they land. Make sure to subscribe if you want more breakdowns like this. Thanks for watching, and I'll catch you in the next one.